Okay, and welcome. Let's start immediately. We're going to be starting by looking at what we did previously. We plan to look at friction and projectile motion today. So let's look at what we looked at previously. We looked at types of motion, oscillatory or vibratory motion, which is the to and fro movement of a particle about a fixed point, as we can see in a single pendulum, or when you pluck the string of a guitar. We looked at rotational motion about an axis, like the Earth rotating about its axis. We looked at translational motion, which is motion from one point to other, as that of a car moving in a plane. We looked at random motion, which is the motion of an object in a zigzag form, like a person moving in a crowded market, or the motion of the particles of a gas. Okay, so those are what we looked at. We gave examples, we solved equations of motion. So today we're going to be looking at frictional force, but before then, okay, today we're going to be looking at frictional force. But before then, let's understand what forces are and the kind of forces we can have. We have two major types of forces. We have what we call the contact force. So the force that you can only experience when there is contact. You have a car moving on a track. So the wheels of the car are in contact with the road. So there is friction. But when you have something on another place and you're having another one, and there is force, just like when you have a magnet and you have a metal, both of them are not in contact, but you can see that the magnet is trying to draw the metal closer to it. So there is a kind of force that is between that magnet and the metal, and that kind of force is known as field force. So the two major types of force that we have is what we call contact force, where the two objects must be in contact, and field force as electric force or gravitational force or magnetic force. So you have the two objects coming together because of a force, but that force is there in existence, but not because the two objects are in contact. So any force like that acts in the environment, not due to contact, we call it field force. So examples of contact force are like push. When you push something, you have to be in contact with it. Pulling, when you're pulling something, you have to be in contact. Reactional force, frictional force, and tension forces. All these are examples of contact force. Whereas field force, examples are gravitational force, electric force, and magnetic force. Because for there to be magnetism, the metal and the magnet, they don't have to be in contact. Once they are close, the force, magnetic force will drag it. So such forces are known as field forces, okay? Chika, do you understand the difference between contact force and field force?
Yes, sir.
Okay. So you could be asked, what are examples of contact force? You'd be able to say that examples of contact force are push force, pulling, reaction, friction, and tension forces. Whereas examples of field forces are gravitational force, electric force, and magnetic forces. So let's get to what we have today, friction. What is friction? Friction is a force that opposes the motion between two surfaces in contact. Very, very important. Those two surfaces must be in contact, like your car moving on the road. The tires of your car, they are in contact with the road, and that's why the road is exerting frictional force, making it impossible for the car to move at its best speed. So that very car is exerting what we call frictional force, is opposing the motion of the car. So you have the force, frictional force is the force that opposes the motion between two surfaces in contact, or objects that are moving relative to each other. So in frictional force, very, very importantly, you need to know about what we call the coefficient of static friction, US, and it's simply equal to the normal force over the reaction force. So it's equal to F over R. Then we also have so this coefficient of static friction is the ratio of the limiting frictional force F to the normal reaction R. And we can also define the coefficient of kinetic friction, which is the ratio of the dynamic frictional force F to the normal reactional force R. Now, you could be asked, what are the advantages of friction? This friction that opposes motion, is it advantageous or is it something that is totally wrong to be happening? So it helps locomotion working, applying brakes. If there is no friction, if you apply brake, the brake might not be able to catch and do what it should do. So friction, one of the major importance of friction is that it helps in locomotion. It helps in walking, applying brakes, climbing, friction belts, grindstone, and banging objects are made to function very well because of friction. So those are the advantages of friction. It helps in locomotion, walking. If you're walking and there's no friction between the your footwear and the ground, you will just slip. You slip and just fall. So friction is very, very important in locomotion, in movement, applying of brakes. If you're driving, when you're driving, there is more friction when you apply brake. That's why your car is able to stop. Climbing too, when you're holding the trees, there is friction between your hand and the body of the tree. Or if you're climbing a cliff, the same thing. The friction helps you to make this climbing motion, okay? Now, what are the disadvantages of friction? It reduces efficiency. That's the most important disadvantage of friction. Friction reduces efficiency. It causes tear and wear of machine parts and brings about reduction in motion. Because of friction, that's why you don't have, if you look at things like high-speed train, they've tried to reduce friction to the barest minimum. That's why you can have have motion to its optimal level. Now, what are the ways you can use in reducing friction? Number one, you can reduce friction by using what we call lubricating oil or grease, using ball bearings and rollers, using pencils and polished terrain. You can use trimming shapes of bolts. When you shape your bolt in a streamlined shape, it helps them to move and avoid friction. Submarines and airplanes. So the design of airplanes and submarine are done in such a way that friction is greatly reduced. Okay, so let's look at, today I want us to cover friction, and I also want us to look at projectile motion. Those are the two things we are going to be looking at, and we're going to be solving problems of them. So we have, in circular motion, it's very good we note angular velocity. So whenever you have a body moving in circle, instead of having the normal velocity, we'll talk about the angular velocity. And there's a relationship between the normal velocity and the angular velocity. When you say the linear velocity V is equal to R, this W sign is actually for angular velocity. So you can talk about the acceleration also to be RW squared. So what are the differences between angular and the normal linear speed that you have, or linear velocity? So you have to talk about angular speed or angular velocity when the motion involves a circular motion. But when the motion is all about linear motion, you talk about linear velocity. Angular velocity can be expressed at theta over t. Theta is simply the angle subtend. You can see this is a straight line. So the angle subtend by this very point B is the theta. So all over t gives you the angular velocity. Whereas in linear velocity, simply have distance all over t. So in angular velocity, you're looking at the theta, that is the angle gone by. Whereas in linear velocity, you're looking at the distance gone by, okay? Angular velocity is a scalar quantity. Angular speed, not velocity this time. Angular speed is a scalar quantity. Linear speed, velocity is a vector quantity. The SI unit for angular velocity is rad per second, whereas that of velocity is meter per second. Now, projectile motion, very importantly, we're going to be solving a whole lot of calculations in projectile motion. So this is a motion that follows a parabolic path. This is what we call parabolic path. Just like when you throw a stone. You throw a stone, it moves like this. Then when it gets up, it starts falling down. So this is what we call a parabola. So any motion that follows a parabola is known as a projectile motion. So it involves a horizontal uniform motion and a vertical motion. So when a body is moving from here to here, you can see that it's taking up this horizontal distance. At the same time, it's taking up this vertical distance. Okay. So very good example is when you fire a catapult. When you fire a stone, it's a catapult. That's a projectile motion. Motion of rockets. Those are all examples of projectile motions. Okay. So in every of your projectile motion, you're likely going to see calculations that involves time of flight. Time of flight simply means the time it took. Let's say you release a stone from here. It goes from here, is the maximum height, and goes and falls here. So that time it takes to go from here and stop here is known as time of flight. And it's simply equal to 2u sine theta over g. Then time to reach the maximum height is the time it takes to go from here to this maximum height h. So it's simply half of the total time of flight. And that's why it is t equal to u sine theta over g. So you can see that the difference between these two formulas is simply the 2 behind here. So 2 times the time to reach the maximum height is the time of flight, okay? Then maximum height is simply given by the formula u squared sine squared theta all over 2g. And range, which is the distance from here to here, is simply u squared sine squared g over sine squared theta all over g. So these formulas are very worthy of note. You have to take note of these formulas because those are the formulas that we're going to be using to solve problems. So take note, t is equal to 2u sine theta over g for total time of flight. Time taken to go from here.
This formula is very...
Yeah, come again, let me hear you. Chika, are you talking?
Sir.
Yeah, Chika, can you?
Okay.
Are you talking? Your network is bad. I can't hear you.
Very confusing.
Okay. Yeah, come again. Let me hear you now.
They are very confusing.
Okay, so let's continue while it gets back. Okay, so these are the 4 very important formulas that we're going to be using. So for maximum range, the angle of projection has to be 45 degrees. You'll see this in your normal Waec problems and your Jamb problems. They will ask you, what is the angle of projection? Okay.
I'll say that in when you get to exam, this it feels like it's easy to mix them up. It has happened to me several times.
Talk loud, talk again, talk louder so that I can hear you.
I said that this maximum height and range are always mixable. Like people mix it up very often.
Yeah, that's true. People normally mix up the 2 formulas. But we're going to use them so that you see the application.
I thought the range was meant to be 2 theta, but this sine square, the range.
Hello?
So did you hear me?
I know your network is very, very bad. But to hear you. Or can you give me a chart so that I can see where
Okay,
you're,
sir.
what you're trying to point out.
Okay, sir.
Okay, so let's keep going. So the angle for projection for maximum range is 45, okay? So let's quickly look at some problems so that maybe during the problems we can address the issue that we're trying to raise. Yeah. You guys are done. Huh? It went through. Okay. So please, I gave you the username and passwords. Please write it for me.
Hello, sir.
Yeah. Are you still there?
Yes, I'm here.
Okay. I'm trying to open up the past question relating to it so that we can solve out some problems.
Okay, sir. I can see it now.
Yeah. So it's showing now. Please, can you see my screen?
Yes, I can see it. I can see it.
Can you see it?
Yes, sir.
Okay. So let's look at this first question. So we're looking at circular motion question as well as projectile. Okay. So we have this Waec question 2013. A body of mass 20 gram projected vertically upwards in vacuum returns to a point of projection after 1.2 seconds. The acceleration due to gravity is 10 meters per second square. Calculate the speed of projection. Okay. So we have options. A is 0.6 meter per second. We have 1.2 meter per second. We have 6.0, and we have the 12.0 meter per second. Okay. So first of all, whenever you're given a problem like this, the first thing you do is that you need to get down the parameters that are given. So you are given mass, which is 20 grams, and it's good you convert it to
Kilogram.
yeah, to kilograms. So you divide by 1,000 to convert to kilogram. That will give you 0.02 kilograms. Then if this body is projected upwards, it has to get to maximum height. And at maximum height, the velocity is 0. And also the acceleration due to gravity is already given as 10. And time is given as 1.2 seconds. So this is the formula that you're going to use, just like I gave us in the formula here, which I already gave in the first one. Said when the motion is circular motion. Okay, in the last class where I gave you that when the motion is a projected motion, that we use, this is the same normal equation of motion, but then we change our acceleration to acceleration due to gravity, G. And we are now using this because we are talking about upward projection. So that's why we have this formula. So we have V is equal to, this should have been V is equal to U plus AT. But because is this type of motion, you have V equal to U plus G, U minus GT. So make U your subject of the formula. So you simply take this to this other side, or you take this here and take this one to this side, so that you have V plus GT. And V, we all know, at the maximum height, the velocity there is 0. So you have 0 plus, this G here is 10 times T. What's the time it took to get to the maximum height? The total time is 1.2 seconds. But the time it took to get to the maximum height is simply the total time divided by 2, which is 0.6 seconds. And that's what we have here. So if you multiply, if you have 10 times 0.6, you have 6 meters per second. And that's why option A is the correct answer. Do you have any question to ask on this so that we can move on? Chika, is it clear?
So I say when you divide by 2.
You say?
Why do you divide by 2?
Okay, I divided the T by 2, but
Yes.
okay, the total time of the flight is 1.2. You understand?
Yes.
But the time it took to get projected to the up is 1.2 divided by 2. You understand? So the body returns to the point of projection after 1.2 seconds.
Okay.
But the time it took to just get up to the maximum height is half of the total time of flight.
Okay.
So if you look at this, this is time of flight. Your network is not allowing me to hear you very well. But if you look at this, this is total time of flight, and this is time to reach the maximum height. So this time to reach the maximum height is 2 times of it will give you the total time. Okay. So time of the total time divided by 2 will give you the time to get to the maximum height.
Okay.
And this formula can be applied to when you're talking about calculation, projection to the maximum height. Check, are we together?
Yes.
Okay, so let's look at number 2 question. Say, determine the potential energy of the body at the maximum height of its motion. So what is the potential energy of the body at the maximum height of its position? Is the option A, 0.36, B, 0.72, C, 360 joule, or D, 720 joule? Okay, so at maximum height of projection, potential energy is equal to the kinetic energy. And we all know that kinetic energy is simply half mv squared. So half mv squared, now you have 1/2. M is the mass. So this question is actually following this very well. So mass here is 0.02. So mass is 0.02. So half mv squared, see, half times 0.02 times v squared. V, we calculated our v here to be 6. So I have 6 here. So 6 squared is 36. So half of 0.02.
That's not the initial velocity.
Yes. So it's actually initial velocity, and that's how you are supposed to use the initial velocity here. Because if you check out the final velocity at the tip will be 0. So you can actually use here u, or use you can use initial velocity. That's what you're supposed to use. The velocity which is used in projecting.
Okay.
Are you clear on that?
Yeah. And so I said,
because if you use 0, yeah, it's gonna amount to 0, because it will be 0 times this, and there will be no energy there.
So if the velocity is always upward, is it equal to 0?
No.
Is it always equal to 0?
The velocity at the tip, at the maximum height. That's
But
what.
they didn't say to the question. How do you know it's maximum height?
I know they said it now. Can you say it here?
No, the up one.
Okay, the up one.
Yes.
Okay.
Like how did you know it's equal to 0?
How we made it equal to 0, right?
Yes, V.
Okay. When you have the motion of a body that is moving from here down to here, you understand? It's also actually making a motion. It's being projected from ground up to down. At maximum height is always equal to the V there is always equal to 0. You understand? So whether they mention it or not, but when you're doing your calculation, you have to take note.
Yes.
Okay. So let's look at another problem.
So is it because of they said that it's projected vertically upward?
Yeah.
Excuse me, sir. Excuse me, sir.
Yeah, because it's projected vertically upward.
Okay.
Yeah. Okay, so let's look at these 2014 past question physics. A body is projected vertically upwards with a speed of 10 meters per second from point 2 meters above the ground. Calculate the total time for the body to reach the ground, where the acceleration due to gravity is 10 meters per second. Okay. So is the option A, 1 meter per second, 1 second, option B, 2 seconds, option C, 2.18 seconds, option D, 3 seconds. So say, okay, given initial velocity, U equal to 0, G equal to 10 meters per second, time taken to reach the maximum height is simply equal to U over G. And time to reach the ground is simply equal to 2 times time to reach the maximum height. Now, T is equal to 2U over G, which is time for the total flight, which is equal to 2 times 10 over 10. So cancel 10, we have 2 seconds. So this one is pretty straightforward.
Like the body was projected vertically upward. Is it because
Hello?
U is in the formula? That's why we used U.
Yeah.
Okay. It depends on the equation. That's when we use the body V is equal to 0.
Okay, are you seeing this one now? Can you see the question on the screen?
Yes, sir.
Okay, this is 2015
Yes, sir.
physics. Okay, a body is projected with an initial velocity u and at an angle of theta to the horizontal. The time taken to reach the maximum height is given by the expression. So what's the formula for the time to reach the maximum height? You know, when we're
over G.
say, yeah, u sine theta over g. That's the time to reach the maximum height. Whereas the time for the whole flight is 2 u sine theta over g. Okay. So it's u sine theta over g, and that makes option C the right answer. Okay.
Okay.
Okay, so let's look at this one. Waec 2016, question 9 and 12 projector. So you have at a birthday party, the celebrant pops a cork fruit wine. So it's, the wine cork is making a projectile motion. If the cork shoots out of the bottle at an angle of 40 degrees to the horizontal and travels a horizontal distance of 4.5 cm in 1.25 seconds, calculate the initial speed of the cork. So is it A, 4.2 meter per second? Is it B, 4.7 meter per second? Is it C, 5.6 meter per second? Or D, 7.1 meter per second? So solution given. So when you want to solve such problems as this, you need to state what we are, the thing that are given, like the range is given as 4.5, which is the distance traveled. The time is 1.25 seconds. The angle of projection is 40. So the initial speed is what you need to calculate. So the formula for these is u cos theta times time. So we're going to make you the subject of the formula. So making you the subject of the formula will now have equal to r all over cos theta times time. So r is 4.5. Cos theta is cos 40 times 1.25, which is the time. That will give us 4.669 meter per second, which is approximately 4.7 meter per second, which is option B. And number 12 simply says, when a body is thrown vertically upwards, its velocity at the maximum height is what? Yeah. Yes, I'm listening.
I didn't really use square sign.
Is it?
I didn't use the.
Your network is so bad. As you're talking, it's just dragging a lot.
Can you hear?
No, come again now.
I said what means
Why didn't we do what?
use square sign theta over g to find the initial velocity. So don't worry, I'll send the question later.
Okay. So this question says, when a body is thrown vertically upwards, its velocity at the maximum height is what? You know, I told you that when you move, when you throw a body upwards, the velocity at the maximum height is normally equal to 0. Is that what I told you before? Is that what I told you?
0.
Okay. So you have option A, maximum, option B, 0, option C, double the its initial velocity, option D, half of its initial velocity. So the answer should be what? B, which is 0. Okay. So let's look at the final one. Okay. So let's look at this before we can, then we'll go to frictional force. Okay, we have this Waec 2017 physics projectile motion. A ball is projected horizontally from the top of a tower, neglecting a resistance. Which of the following statements about the motion is or correct? Number one, vertical acceleration on the ball decreases as it falls. Vertical acceleration decreases. That's not possible. Vertical force on the ball, the force is constant. Now, the vertical speed of the ball increases. As the ball is falling, the speed as it gets to the ground is always increasing. So we have option 2 and 3 should be correct. Option 2 and 3 to be correct. One is never correct. Okay.
What about number 2? They said the vertically force.
The vertical force, the force that you apply is actually constant.
Okay. Yeah.
Yeah. So let's look at this one. The angle at which projectile must be fixed in order to get maximum range is what? I think we said that during the question. What's the angle to get maximum range? In the notes, we said the angle of projection for maximum range. So what's the answer? From this, what do you think is the answer?
55.
Option what? So the answer is option B. For you to have maximum range, the angle of projection should be 45. Because sine 2 theta should be equal to 1. So you can see it here. Sine 2 theta should be equal to 1. So that you have, for you to have maximum height, it should be option B, okay? So let me get us problems on friction immediately.
Okay.
So don't worry, any question that you have, we'll take a look at them once I'm done with it. I hope you're enjoying these ones are Waec questions. It's okay by you, huh? Are you there? Yeah, how are you? Hey, my brother, how now? Well done, fine, thank you. How's everything? Well done. Chika, are you there? Yeah, are we there?
Yeah.
Okay, so let's look at these friction problems.
Okay.
Yeah, so this is Waec 2013 physics question number 4. A block of wood, this is the block of wood of mass 5 kilogram is pulled on a platform by a force of 40 newtons. This is the force pulling it. As illustrated in the diagram above, if the frictional force F experienced by the block is 12 newtons, so the frictional force that is opposing this motion is 12 newtons. Calculate the magnitude of the acceleration of the block. So what is the acceleration? So whenever you have two forces like this, the resultant force has to be the force moving it minus the frictional force. So when you equate it to mass times acceleration, because F is equal to ma, then you can be able to solve it. So the options are A, 2.4 meter per second square, B, 5.6 meter per second square, C, 8.0 meter per second, D, 10.4 meter per second. Okay. So given the force is 40 newtons, mass is 5 kg, A, acceleration you don't know, frictional force is 12 newtons. So the force pulling it minus the frictional force will give you MA. So this is what we call the resultant force, the pulling force minus the frictional force, which is equal to MA. So simply make A the subject of the formula. So we have 40 minus 12 is equal to 5K. 40 minus 12 is 28. 28 over 5 is 5.6. So that makes A acceleration is equal to 5.6. So Johnson, is that clear?
Yes, sir.
Okay. So let's quickly look at another problem. I hope you're able to see my screen.
Yes.
Okay. Let's look at another question. Okay, Chika, you just joined. Did you just join?
Okay, so.
You just joined, ba? Okay, so let's look at the number 2 question. Then I'll look at the one I previously solved. Are you there? Chika, are you there? Okay, so this is Waec 2013 physics past question. So we have a solid friction like viscosity is. So solid friction just like viscosity. What's the effect? It's independent of the surface areas in contact. So can this be true? Friction is always dependent on surface area. So you cannot say that friction is independent of surface area. So that makes A is not even close there. B, independent of the relative
Motion between
the areas. No, friction is actually dependent on the good. So A and B can never be the answer. C depends on normal reaction. Then D is opposite to the motion. We all know that friction is normally opposite to motion. So that makes D the direct answer. Friction is a force that opposes motion between two surfaces in contact and moving relative to one another. So that makes option D just the direct answer without any problem. Okay, so Joe, you just joined. We looked at projectile motion. So I'm gonna send the problems we solved to the YouTube to the WhatsApp group so that you see what we did before now.
Okay. Thank you, sir.
Chick, are you here now?
Yes, sir.
Okay, so this is we just looked at problems in friction. You know, we looked at friction and projectile motion. So, and this is a Waec question number 4. 2013. A block of wood of mass 5 kg is pulled on a platform. So you see, this is the wood and it's being pulled. So this block is 5 kg. This is the pulling force, 40 Newton, as illustrated in the diagram above. If the frictional force F, so this force that is frictional, that is opposing this main motion, F, is 12 Newtons. Calculate the magnitude of the acceleration of the block. Okay. So these are the options: 2.4, 5.6, 8.0, and 10.4. So how do you calculate the force? You know that force is equal to mass times acceleration. So what is the resultant force on this object? So the resultant force is simply the force that is pulling it this side minus the force that is making it not to move in that direction. So it's 40 minus 12. So that is the resultant force. So if you are talking about force is equal to MA, it has to be a resultant force, which is the normal force minus the frictional force. So equal to MA. So the normal force is 40. The force that is pulling it to this direction is 40. You know, the friction is opposite. So the resultant force has to be that normal force, the pulling force minus the opposite force, which is the frictional force. So we have 40 minus 12, which is 28. I'll make A the subject of the formula. So it becomes 28 all over 5. I hope you know this formula, F equal to MA. Force is equal to mass times acceleration. So So that's the simple formula that was used. So if you do 28/5, you get 5.6 meters per second. Is it clear?
Yes, sir.
Is it clear?
Yes, sir.
Okay, after that, then we looked at this number 2 question. Solid friction like viscosity. This one is simply trying to ask us what friction is all about. You know that friction in fluid is called viscosity. Are you aware of that? Friction in fluid is viscosity.
Okay.
So it's asking us, what is it about? So option A is independent of surface area of contact. This cannot be the answer because friction is actually dependent on surface area of contact. So B, dependent of relative motion of the areas. We also say that friction is actually dependent on relative motion. So this one cannot also be the answer. And this one is dependent on normal reaction, and this is opposite in motion. We all know the definition of friction is simply that friction is the what it opposes the normal motion. So this just makes option D the direct answer because friction is the force that opposes motion between two surfaces in contact, moving relative to each other. Okay, so I saw your chart. I opened the chart and saw the what you are asking about the formula for range, Abby. That is supposed to be 2 theta instead of theta, isn't it?
Yes, sir.
Was it your question, Chika?
Answering, yes, sir. Answering that question, we didn't use it. We used arrow cos something. Why?
Yeah. Yes, we can also use cos when we are solving for range instead of this, but this is the normal standard formula.
So if you use this, you still get the same answer.
Understand? Yeah, but you have to consider what you are giving. You understand? You almost use this one when you are giving all these variables. You understand? But if you are not giving all of them, then you use the formula that will help you solve, given the variables that you're using.
So why did you use that cos?
Yeah, so it depends on what we are giving. You understand? Whether you use this one or that one, it will still give you the same thing.
Okay, sir.
But always use the parameters considering the variables that are actually given to you.
So
I'll send all of them to your WhatsApp. Then
So this formula now for range, is it sine squared theta? Or is sine 2 theta?
Yeah, it's 2 theta now. That was the mistake that
I said we made. Is it meant to be?
It should be 2 theta.
Okay.
You asked the question, but.
Oh, okay. Okay, sir.
Yeah, it's meant to be 2 theta. Yeah.
Thank you, sir.
Yeah. Okay. So we'll discuss more on the charts. Yeah. Thank you.